Hello, everyone. My name is Molly Halsey, and I'm the event specialist here at Enterprise DB. I will be your host today for our webinar, Oracle to Postgres Schema Migration Hustle. I'm joined today by Mark Linster, SVP of Product Development, and Raghav Rowe, the Managing Consultant in the Professional Services Division. Before we get started, I just want to go through a few housekeeping items. This presentation is being recorded. We will be sharing the recording along with the slides after the broadcast. The lines are currently muted. If you have a question, please feel free to submit it in the question panel. Today's session is scheduled for 45 minutes. We expect the presentation to last most of our time today, and we will allot any extra time for Q&A. If we do not have time to address all questions, we will follow up afterwards for all of those questions that were not answered. Now, without further ado, here are Mark and Raghav.
All right. Thank you, Molly. Thank you. So, as Molly said, Raghavendra Rao is going to join me today to talk about migrating Oracle schemas to Postgres. So first, this is part of a webinar series. If you're interested in this topic, come back in 2 weeks where Raghavendra and I will talk about data migration from Oracle to Postgres. And then early March, we'll talk about how we use Terraform and Ansible to deploy highly available Postgres. And then mid-March, Raghav is going to join us again to discuss 5 things you need to know about Postgres.conf. This whole webinar series, as Molly said, is recorded and available. So if there's anything in the past that you'd like to go back to, just take a look at our website. Okay, so the agenda is briefly, I promise I'll be real brief. I'll talk about who is EDB, and then we'll dive into, migration overview, differences, how to deal with them, and then I think very important is different tools that are available to you and the pros and cons of those tools, what they're good at, what they're not so good at, give you an overview, what's available, where to download it, and how to make a decision. So very important. We have a giveaway here, and Raghav, if you can just show people what the socks look like, and everybody will get a pair of those socks if you ask a question and give us a shipping address, please, in the Q&A chat. Okay, so ask us a question. We'll answer the question if we have time at the end of this. Otherwise, we'll do it in writing afterwards, and we'll send you a pair of these nice and comfy EDB socks. Okay. So going forward, let me just talk briefly about who EDB is, and it's important to understand that in the context of this webinar, because we've been doing Oracle compatible version of Postgres since 2004. And we've been recognized for our work by Gartner and Forrester. Today we have over 4,000 customers, 300 employees worldwide, and we are a major Postgres community contributor. Many customers come to us because they want to figure out how to get away from the big commercial databases like Oracle, and then they stay with us because Postgres is really a very, very innovative vehicle, not just for migrations, but mostly for new applications, for complete replatforming, and for digital transformations. I mentioned that we have had quite a bit of success with Gartner, and we've been in the Gartner Magic Quadrant now, so Enterprise DB Postgres, for 7 years. And we've been in there since Gartner restarted their Magic Quadrant in 2013. We are positioned today as a challenger, which we're very, very proud of. And we're doing very well along the lines of ability to execute, which basically means, do we have the consulting, do we have the tools, do we have the support, do we have the worldwide presence to support large enterprises? And Gartner says, yes, we do. And do we have the completeness of vision to give our customers everything that they need in this space here? So that's been a very, very good achievement for us. And I want to drive your attention or direct your attention to one important thing, which is what's missing on here. And what's missing on here are all the other open source relational database management systems. They are not in the Gartner Magic Quadrant any longer. If you page back to the past, you will see some of those contenders, but by now they've all been dropped out. So as said before, we have lots of customers. Obviously, very proud of those. Here are a few that I can name. I'm only emphasizing these here to help our audience understand that we're doing Oracle migrations and replatforming and new applications for very large customers, not just small customers. And I've personally worked with quite a few of these, and I know that their applications are really large scale, mission critical. So they need 4, some even 5 nines of availability. They need a type of monitoring that's usually associated with Oracle, a type of high availability that's usually associated with Oracle. And we've been able to prove to them that we can do more than just move the code from Oracle to Postgres. We can also run the application with comparable availability and readiness for mission criticality. We're not just active on the commercial side. We're very, very involved in the open source development. So some of our team members have been with Postgres for a long time, such as Bruce and Dave, been driving this forward. Bruce for nearly 25 years, Dave for over 12 years. And then others that you may know, such as Robert Haas or Devram Gunduz, Amit Kapila. You will probably know Devram Gunduz indirectly if you've ever downloaded a native package, such as an RPM with Postgres in it. Devram has his hands on those things and makes sure that happens. And he's involved in a lot of the packages that you would get from PostgreSQL.org. Robert's been the key architect behind parallelism in Postgres, and Amit and his team have driven a lot of the performance enhancements, contributed significantly to locking improvement, etc. So we're proud of this, but we'd also want you to know that this is the kind of company we are, working with commercial companies, but also very invested on the open source side. So when we talk about successfully migrating, we really know how to use the power of Postgres to get customers there. Okay, so now before we get into the migration overview, I'm going to turn it over to Molly for a quick survey, and obviously we'll share that survey data also with all participants in the webinar. So Molly, it's all yours.
Yes, so we have a quick survey for all of you. The question should have just appeared. It is, what are your migration plans? Are you already migrated from Oracle to Postgres? Are you planning on migrating from Oracle to Postgres? Are you planning on migrating from another database to Postgres? Or do you have no plans to migrate from Oracle to Postgres? I'm going to give everyone just a little bit of time to answer. We've had about 40% of the audience voted. Before I will show you the results, we're at almost 60% of the audience voting. I'm going to give it another 5 seconds for all of you. We've just hit over 70% voted. All right, I'm going to open up the results. Here are the results. We had 7% saying they've already migrated, 59% planning to migrate from Oracle to Postgres, 9% planning to migrate from another database to Postgres, and 25% have no plans to migrate from Oracle to Postgres.
Right, thank you. So we'll add that to the slides that we'll send out afterwards. Now I'm going to turn it over to Raghav to take us through necessary awareness that you need to have and potential challenges, and then we'll talk about the tools. Raghav?
Yeah, thank you, Mark. Let's give the control.
One moment.
Okay, we should get there in a minute. I mean, that's always what happens when you do a live thing. I'm actually in Miami in a hotel room, and Raghav is in our headquarters in Bedford. So, but I think sounds like now we're ready to go. Raghav, please put your slides into presentation mode.
Yeah.
Okay, it's all yours.
Thank you, Mark. Okay, we're going to talk about the migrations. Migration is a big word. Like there could be many types of the migrations. Today we'll be talking about database migrations. And in this database migration, what you're going to do is you're changing one database platform to another database platform. So it could be moving the whole definitions, data, and the stored procedures that are in one platform, and you're moving to the other platform. There could be many reasons why you move. It could be a cost, it could be a support, or you may like some of the features that are there in other platform that you want to use for it. Now, when you decide to do these migrations, the database migrations, the first thing is a preliminary check. So what is the preliminary check here is you need to see in a three-tier application whether the client, the application server, and the data access and the RDBMS you are connecting all are in compatible mode or not. That means you need to make sure that the DBMS you are changing, you are migrating from one database to the other database, the upper layer is also compatible or not. So in this preliminary check, what you're going to see is the application server that it's a language dependent, and you need to have an data access that will connect to the RDBMS that is compatible or not. So you need to make all these in line when you decide to do database migration. So particularly in here, I would like to stress one point about drivers. These drivers are very important because they will talk to the RDBMS backend RDBMS because they have its own protocol language, and they convert your SQL server your application server SQL statements into their protocol language, and then they try to run it on the database. And when a database gives a result set, they convert into their protocol language and give back to the client. So when you decide to do a database migration, you need to make sure the client, application, and the database all are in compatible state. Once you make sure that these are all compatible, then you can start, you can go next step to migrate the schemas, or how do you migrate the database and all that. So in my opinion, preliminary check is the important piece. So you need to know upfront what are compatible. I'll give a small example here, like in Oracle, there could be something that is compatible in Postgres. You migrated it, all went well, but your driver is not yet able to convert the results at what you are expecting. So in that case, your migration may be successful, but your drivers are still not compatible to that layer. So that's why you need to make a note of all this, see that these are all compatible. Now, here we are talking about Oracle to Postgres. So Oracle to Postgres, there are many differences. I don't want to highlight all the differences here because since we are talking about database migration, I captured few differences that are relevant to this webinar. This is relevant to the people who are really want to do the migration, and they need to know these differences upfront. So I'll list out these as one. Oracle uses its a TNS protocol. It runs on 1521 port, and it uses OCI library. For Postgres, same TCP/IP port, but default is 5432, and it uses libpq library as a native call interface. In Oracle, like the transactions are not auto-committed whereas in Postgres, these are all auto-committed. That means you run a transaction that is committed by default. Now, how do you control it is, at a Postgres side, what you have to do is you need to open a begin block. So you'll get a control how to commit and roll back. Now, this is at a transaction level. And do we support isolations? Yes, all the isolations are supported, same like Oracle. And the default is read committed in Postgres, which is very much sufficient to handle the same Oracle kind of a transactions. Now, next is the drivers. As I discussed in the last slide, you need to know what are the drivers supported. So you may be coming from a different languages. Your application may be using a different language approaches to connect to RDBMS. So you need to see what are the drivers supported. In Oracle, it supports many drivers. In Postgres also you have a similar drivers, but there are few, and they are standard drivers where is enough to convert your application. I mean, your application can listen to the RDBMS. Next is packages, procedures, global concept. This is basically used in Oracle, and this is the core functionality of Oracle when you trying to do some manipulation to the data. But these things are not there in Postgres. But how we do it, that is a incompatibility challenge that we'll discuss in our next slides. Next is support to other language. That means your Oracle database can invoke other languages functionalities also. For example, you can have a Java in your Oracle database, or any PHP, or any language you can enable in Oracle. Same way with Postgres also. It also support a good set of languages, not as much as in Oracle, but it will support a good set of languages. Next is partitioning. We see a lot of partition because we are talking, as I said, we are talking about migration. So partition is also a key concept. So there are different varieties of partitions in Oracle. In Postgres today we support a range and list as part of PostgreSQL 12. Right now we don't have any other partitions like hash or virtual, like these partitions that Oracle supports is not there in Postgres. I'll touch one small point, that is replication. Postgres has different types of replications, master to master, master slave, and it's a big concept actually. But at a very high level, if you ask me a question that Postgres support replication, yes, we do support a replication, and it has a simple master slave replication. Now, these are the differences. Now, you should know these differences at very basic level, because you are looking to migrate your Oracle database to PostgreSQL. Now, once you know these differences, let's move on to the schema migration hurdles. Like one of the schema to be migrated, then what are the challenges you're going to face in this module? Now, so if first what we have to do is you need to know which schemas you want to migrate to Postgres. Okay, from Oracle today you decided, okay, I want to move 10 schemas. Then out of 10 schemas, which one to choose? I would say I will start with very small one, because there are many things involved. You need to have a team that has a good knowledge between two databases, and they are good experienced, and you should have a developer who can quickly understand the functionality of Postgres, and he could be able to convert that to Postgres. So I would say take a small schemas which has very few code objects or few PLSQL objects, and after that, once you have an experience how to convert, how to migrate, then you move on to a big schemas. Okay. Now, what you should not choose here is, it should not pick the very tough one, and you spend a lot of time, and then you don't see it is it's compatible, and you couldn't able to migrate it. Your project should not fail there. So that's why see the schemas that are not closely tied with OCI. That means OCI library-based schemas are designed by the Oracle. That means Oracle's library. It is closely tied with Oracle libraries. If you try to use those schemas and try to convert and try to map with PostgreSQL native libraries, then there is a lot of work. So a lot of money. So I would say not to choose those. And proprietary softwares like corely tied with Postgres database, like Oracle Forms. Don't choose those schemas. And spatial schemas. Why I would say no to spatial schemas? Because there is a slight difference in Postgres. Postgres has a spatial schema also. Like we enable PostGIS extension. Using that PostGIS extension, you can achieve the same spatial functionalities. But there is a slight catch here. The syntax-wise, there is a functionality-wise, they're slightly different. So if you start choosing that, you need to convert each and every object. So that will become a lot of manual work. So that's why don't pick the difficult targets. Pick the easy targets, convert them, get some experience, and then pick the higher one, and then you make use of the Postgres functionalities. So once you decide a schema, now we need to know what all will be there, what all objects will be there in this schema. Okay, so every RDBMS comes up with this schema concept. So this is just a logical container where you can keep your objects. So if I want to classify this one, it is in two types. One is storage objects, where your application do some manipulation and then it want to store some data inside the database. And code objects are those which acts on the storage objects and like do manipulation and then send the data sets to the application. So these are the two categories of objects that we're going to migrate to Postgres. So just remember storage objects and the code objects. So storage objects which holds the data and code objects which operates on the data. That means you can program, modify on the data. Now these schemas, once you know a small schema and you know, okay, there are storage objects and code objects. Now let's see what are the challenges. That means you decided on one schema. Now you want to migrate that schema to Postgres. Now, what are the challenges you will face here? Because all tables, views, packages, functions, all this should go into Postgres. Then only your application will work, right? So when you want to migrate this one, it's not straight away migrated into Postgres. Why? Because there is a RDBMS. It's a fundamental difference. It could be a syntax, it could be a functionality, or it could be something that an application is expecting and the behavior is entirely different on the Postgres. Okay. Now we're going to see all these challenges in this from here onwards. So once you decided a schema, right? In Oracle, a schema is like a user. That means if you connect to Oracle as a user, you will get a schema, and inside that schema, you store all objects. It could be storage objects, it could be code objects, everything you can store in that schema, right? And that belongs to that account. Now, coming to Postgres, users are a little above the schemas. That means users can create schemas. Okay, they can give permissions to other schemas, and it gives a lot of flexibility to the application. That means a user can connect, and by default he'll get a public schema. After that, the same user can create a different schemas also. Okay, and he can store those objects there. So it's like in a logical container where you can keep different set of objects. If you have a finance related objects, you can create a finance schema and keep those objects there. Same wise for employees, and you can give a permissions between those two schemas, so the user will get access to those objects where he has permissions to it. By default, he connects to one schema, but he can access the other schemas also. So it gives a more flexibility to your from application point of view, that you can separate the objects into different schemas. Okay, so this is the one place where most of the users uh, see there is a difference here, but I would say it's the same. But you'll get a more flexibility in Postgres, because uh, though the concept wise, like one object, a user creates an object and the other user want to access it, he need to have the grants and privileges. That's the same concept here. But in Postgres, you'll get more flexibility to divide the data objects in a different logical spaces, namespaces. Now, next another important thing is about is identifiers. Like in Oracle, whatever you create, all are in uppercase. Okay. Now in Postgres, when you convert these object types, it will be in lowercase. That means you need to explicitly put a double quotes to make it as an uppercase. Okay. So if your application is not putting any double quotes on the identifiers, then that is fine. That means you don't need to do any manual work for it. But if your application puts a double quotes, that means it is explicitly asking for uppercase. So it's just, then you need to see from your application and this is required or this is compatible in Postgres or not. On that basis, you need to do a change at the database level, also at the application level. Now, coming to the storage objects, okay, those two are the global related, so I would like to talk on the storage objects. Tables, most of the tables are compatible. Like that means when I say compatible, that means you can create this same ANSI SQL tables like that. And coming to global objects, global temporary tables. So this is not supported in Postgres. That means there is no global concept, so you need to rely on a local temp or unlocked tables. And in Oracle, it will give a different concept of keep, cache, IoT, external, compressed, cluster, and nested. All these are treated as a normal tables. Okay, and how you get the same functionality is convert into a Postgres as in a normal table and use the Postgres modules to get the functionality. Next is partition table. Partition, as I said in the differences, we support only two types, range and list. And on that basis, you need to convert the other subpartitions or other functionalities to match with the supported range and list. Next is constraints. All constraints are supported. Suppose if you want to make a foreign key reference with a partition with a partition table with a non-partition table, then that is a limitation. There you cannot make a reference key in the constraints at the Postgres side. And indexes. Indexes, most of the indexes are supported. I would say only two are not supported. That is reverse key and global. So there is no concept of global index in Postgres. That means you cannot create a partition table a global index like that. In reverse key, that means you need to depend on a functional based index. So you'll get a similar functionality. And next is about types, user defined data types. Yes, that is supported. You can use create domain or create type, or there is also support of arrays. Okay, you can make use of arrays, so you'll get the same functionality of composite types. And sequences, Oracle gives a max value, but in Postgres you have a limit up to 2 to the power of 63. And if you have a schema definition like no cache, no order, those are not supported. It will become cache, and there is you need to trim off these important tokens from the definition, so it will be migrated to Postgres. When you create a sequence in Oracle, you can simply say .next .current val, but in Postgres you need to call as a function like next val current val. Going to synonyms, synonyms are not supported. What is a shortcut is like you need to create an object or a view, and again you need to enable a search path so that you will get that functionality as a synonym. Now, coming to the data types, those are the storage objects, how you handle it. Now coming to the data types. Data types, varchar, varchar2, all will go to varchar or text, and you have another function, another data types called char and char that is also mapped with char. Clob, long, varchar or text. These are the compatibilities I have given here. So if you want to convert the Oracle data types, you can convert with the other column, the second column, what I've shown in the Postgres. Now coming to the number, you'll have scale and precision. You have a big, you can convert to big int or int or small int, real or double precisions. So you don't have a.
What does that mean? So in Oracle, I could say number, let's say 3,2, but what's the equivalent in Postgres?
In Postgres, it will be double precision, where it will give the same functionality, but it may not give a control of scale. So, for example, in Oracle, if I say there is a number 3,2, okay, that will be a 9.99. That is the max value you can store in Oracle. And in Postgres, that will be a double precision, where you cannot give a scale, but a scale or a precision, but a double precision is the one that will allow you to get that functionality. Okay, next is binary integer, binary float. These are all mapped to integer, float, blob, raw, long raw to byte. Size, there is a slight size limitation on the Postgres side. Byte will go up to 1 GB. So you need to make sure the data, while migrating the data, you should make sure that it is compatible. So here is one where you need to focus, like whether these data types will go, this much data will go into these columns or not. So according to the size limitation, you need to handle this these rows separately. And other data types like date, timestamp with time zone. These are all specific in Oracle. That means if you create a date format data type in Oracle, in Postgres also it's same, but it will come up with a timestamp. That means by default a timestamp is added there. And if you want to create a time zone with timestamp with time zone, then you can use timestamp TZ. Not only this, I have listed very few here, but there are few more in Postgres. Like if you want to store IP addresses, you can use CID, CIDRs and INET, and you can also use arrays. So those that are not. For example, I'll give you a simple one like Boolean data type is not there in Oracle. You can create in Postgres. So there is other way that Oracle uses, but in Postgres directly you can create a data type called Boolean, and then you can store true false there. Now that is related to the storage objects. Now let's move on to the code objects. So this is an important piece here. I'm calling it as incompatibility. That means you need to do a manual work here. Like these are all things what I'm going to discuss from here on. You need to do a manual work. That means it may not be supported directly in Postgres. That means you need to edit, modify the syntax, or sometimes you need to work around it like that. You need to do some changes at Postgres end to your code objects to make it to migrate it to PostgreSQL. So these code objects I'm pointing to packages, procedures, and functions. So these things will come in that category. So if I take first as a return statement, so that means in function there is a return type that converts to a returns. Execute immediate, that means it's a dynamical SQL you want to use, then you can use execute. Sometimes in function you call a select statement where you don't want a result set. Okay, Postgres won't support you to create a select statement without into clause. Okay, in that case, how you use it? Use perform. So perform is an option for you to run select statement without result set. Now coming to the functions, uh, function should close with a language. That means in Postgres, in Oracle, you no need to call a function language when you create. In Postgres, when you create a function, you need to call a language. That is a mandatory in the syntax. Now, you can declare a variable with a type or row type, and your cursor with row type is supported in Oracle, that is not supported in Postgres. Then what is the workaround for it is use record. Okay, that way you can declare your variables. Coming to autonomous transactions, this is very frequently used in Oracle. So that means a transaction is independent, and it will go out of the parent transaction, and it will commit and roll back. So those things are not supported in Postgres. So how you use it is use a dblink module. That means if you want to go out of the parent transaction and do some modification, then you need to rely on a dblink module. That means you need to enable a dblink extension and call within that transaction. Okay, this will comes with a slight overhead, uh, but that is the only one approach you can pick in Postgres for autonomous transaction. Next is commit rollback in a procedure. You cannot call a utility commands like commit or rollback in procedure. You need to use a exception handling. So using the exception handling, you can retry if it is failed, or you can do any modification in the exception block. So you need to use the exception block in a procedure for commit and rollback. Now next is for statements, I mean loops. In a procedure, in a function, you may call a reverse loop. In the syntactically, the functionality is supported. Syntactically, there is a slight difference. So if you call a reverse loop in Postgres, you need to explicitly mention the start end condition. If you're not mentioning it, it is not compatible. So you need to explicitly mention. In Oracle, you no need to do that. Now coming to the packages, as I mentioned in a differences section, packages are not supported. That means how you want to migrate that one means you need to rely on some of the extensions. Since Postgres do not support a package concept, but you can group set of your functions procedure into one schema and handle the grants and privileges on that schema. But still, you won't get that level of functionality, frankly speaking, because there is no private variables or private function support. So that's why, though you group it in a schema, still it will be challenging for you to migrate. So in that case, there is a Aura FC. This is a open source module which will create some of the DBMS package functionalities and some of the built-in functions. So you can make use of this library for packages. Now coming to accessing to remote objects, this is a common requirement when you are working on the migrations. You may want to access a data from Oracle to Postgres, or you may want to access a data from Postgres to Oracle, vice versa. You want to do anything, but from Oracle point of view, you can access the Postgres data also using heterogeneous service. It gives a heterogeneous service where you can use a ODBC driver and make a connection to Postgres and get the data. But how do you do it in Postgres? Postgres, you have a DB link module. You can go within the different cluster or different databases, or you can use a foreign data wrappers. Using the foreign data wrappers, you can go to other databases also, non-Postgres databases. I given a small example, Oracle FTW. You can use Oracle foreign data wrapper where you can connect to Oracle server and access the data. Now, next is optimizer hints. There is no concept of hints in Postgres. If you have a SQL statement that has a hints in it, and if you want to convert that or you want to execute it on a Postgres, those hints are not validated. Those are all discarded. That means you no need to do any conversion because it will be in a comment section. So those are all discarded and your query is executed as per the PostgreSQL planner, PostgreSQL optimized planner. So no conversion is required for optimizer hints. Now, the other thing here is query conversion. Your application will build so many dynamical SQL statements to get data from the database, right? There are some queries that may use pseudo columns, that may use hierarchical queries, that may do some joins. So when you're doing a joins, right, there is a concept of plus sign in the where clause that is supported in Oracle, but the same way it won't work. That means you need to manually do these changes. That means edit and modify the query. How? Like you need to change it to a full outer join or a union clause. So then your query will give the same results that how you are using for outer joins. Pseudo columns. This is very frequently used by the application queries, like row number to get only 10 rows or 15 rows. In Postgres, use limit clause. Okay, limit clause will give the similar functionality. Row ID, in Oracle, it's a physical address. In Postgres, CTID is a physical address. But these will change. Like if you do a vacuum or do some cluster on a Postgres SQL table, the CTIDs will change. The physical address, physical location will change. You need to see the query why you want to use the row ID. So it could be a simple number you want, row number you want, or what exactly you are looking. So on that basis, you can convert these queries. I would say use row number over Windows function, so you'll get the row position in Postgres. And hierarchical queries. This needs a lot of manual work. That means you need to edit and rewrite the queries using recursive expression, like using CTE or table function. It's in a module. It comes with set of functions. It gives a similar functionality like your connect by prior or level or path. You can use some of the table function modules for hierarchical queries. And another last incompatibility is empty string versus nulls. So in Oracle, if you say empty string equal to null, both are treated as null. But in Postgres, it's slightly different. So the queries that are called by application will work on Postgres without any issues. But the thing is, the data set, what it gives to the application will be slightly different. So we should be very careful when you have some queries with empty string versus null comparison. So you need to check the result sets. Okay. So because the behavior is slightly different in Postgres. So that's why you need to manually edit and need some special attention to those queries. Built-in functions. These are the few functions commonly used in a queries. So that is important. So that's why Oracle uses these functions, built-in functions in queries. The equivalent is for NVL use callsec, or for decode use case clause, or sysdate use current timestamp. So these are the some methods you can use to convert in Postgres and get the similar functionality. Now, so far we have seen all the incompatibility challenges, like its schema, how it converts, what all the changes you have to do to data types, procedures, okay, the DB links, identifiers, and everything. Similarly, there is one option I see is advanced server, Postgres advanced server. This database is built on Oracle compatibility. That means uh, if you want to run some of the Oracle type queries, you can run on this database. You don't need to do any changes. Okay, that means if you try to call a select statement that has optimizer ints or anything, you can call the same thing here also. You get the same data types, same functionality in advanced server. You can try this one of the options. So what it supports. Yeah.
And this also supports autonomous transaction, right? So you don't have to do the DBMS link thing. You can just use autonomous transaction, right?
Correct, Mark. So autonomous transaction is natively supported, so you no need to enable a DB-link module and call a DB-link for that transaction. So it is natively supported. That means the user, Oracle user, he's writing an autonomous transaction procedure. He can just copy paste it in advanced server. He'll get the similar functionality. So no manual work, no edits. So what all supported, I'll give few points here about what it is support, like data types. We talked about the data types. Here you'll get a control of scale and precision. Database links, same database links you can create in advanced server. You can create a synonyms, public, private sequences with max values. Partition, subpartition is supported. That means you already having a subpartition, then you can just use the same syntax here. That means it's compatible. There is a limitation there. Now you're not, the subpartition is up to range and list today hash, and not like virtual and all partitions. Same wise, you will have built-in packages functions. That means not all the packages. You no need to enable a module here like ORFC module to have the same packages. Natively, these packages are created in advanced server. That means you can call as it is, like dbms underscore output line. If you are using, you can directly call it in a procedure. There's no change, no separate libraries required, no module you need to enable. It's as it is. You have a dbms RLS, SQL protect and policies for securities, and UDTs. This is very highly used at Oracle side. You can use the same type UDTs in this, and there is also support of drivers. Uh, if these functionalities are inside the database, definitely that should be in your drivers. That means the result set what you are expecting from the database should have a conversion in the drivers also. So that support is also there in advanced server. This is another option where you can reduce migration exercise work. So because natively it is all supported, you can make use of this database as well. Now, coming to tools. So tools side, I will discuss few of the tools, how these tools will help us to migrate Oracle schema to Postgres. Okay, and to what extent they will do. That means they will convert or assess, or they will do a data migration, all that. Open source tool Ora2PG is one of the known tool where it will do an assessment and it do some conversion, and it will also do a data migration. I will go in detail about these tools, but I'm just giving a high level picture. Free to use tools are AWS schema conversion tool. You can use EDB migration portal. It is also has a conversion and assessment. EDB migration toolkit. It won't do an assessment, but it will get you to the Postgres, including data and the object definitions. I will go more detail about this one. And there is another supporting tool, as I discussed in my previous slide, ORAFC. So this is a library where you can enable some of Oracle type of built-in functions and packages. So your procedure will call call a Oracle kind of a built-in package and functions. So these are the tools I have classified that are useful when you are doing migration to Postgres. It's a Oro2PG sample report. Uh, uh, it will give a high-level picture of estimation, number of days it takes to convert, and what all objects you need to convert, and where is the manual work required. It will give a report. That means it connects to your source database, it connects to your target database. It will do the assessment, and then it will also do the conversion to the target and creates the report. This is Oro2PG sample report. And and another one is EDB migration portal sample report. Uh, Here you can see it targets to EDB advanced server Postgres database, and when it connects to source database Oracle and try to convert to target, it will tell you what all it has converted. That means how many objects it has converted natively. That means it won't do any conversion. It will natively support it in the advanced server. But if if there is a change, that means if you need to do some modification to the object, it will tell what all the objects it has repaired and modified it. Similarly, you can see AWS SCT Sample Report. This will also do a conversion, and this is a simple sample report. After conversion, it will give a list of the objects, whether what it has converted or it needs a manual effort or not. All this information is given in the sample reports. Now, this is a this is high level classification of all the tools, the four tools what I have discussed in last slide. If you see the EDB migration portal, uh, it does the assessment, it migrates the data objects, and it converts the code objects. Very few you need to manually edit and modify, but it converts most of the objects because your target is Postgres Advanced Server. So if you see the right side column, all these tools I am showing towards the target. This graph is towards the target. For example, if you take Oro2PG, my target is to PostgreSQL. So what I'm doing is it does an assessment, full assessment. It migrates the data objects. Yes, some of the data types is not supported, so you need to modify that. You need to convert that. And some of the code objects it won't convert. Like for example, we have talked about DB link and all that. It will do some transformation to convert to PostgreSQL. So there is some manual work involved there. And same with AWS SCT. It do an assessment. It tells you what all the objects that needs a manual work, and what all the objects that can migrate automatically. So it also do a slight transformation of the code.
Maybe it's just me, but I think we've lost audio.
Can you hear me, guys?
Yes, now we can hear you.
Right. Okay, I was talking about the migration portals, the last one. It will access your SQL file. That means you generate a SQL file in Oracle, and that will come up with all list of definitions, and that definitions are uploaded in the portal, and it will do an assessment on it, and it will do a conversion, and it will also allow you to edit and modify the object according to native Postgres advanced server. That means if one of the object is not compatible to Postgres plus advanced server, in that case, it will give a list of solutions to you where you can use those solutions, modify the object, and it is created on the advanced server. So this is a set of tools where you can try to convert your Oracle schema to PostgreSQL. Now, what all? This is a final slide. Um, it's a summary of what all we have discussed. Is first, when you decide to move to Oracle to Postgres, this is the steps you need to follow. One is assess. That means you need to pick a schema, small schema, or as per the three-tier architecture, and then do the conversion. Use any tools. See which tool will fit to convert this schema. Do the conversion. Once the conversion is over, allow your application to access that schema. That means do a functional testing. Once the functional testing is over, you need a performance testing. That means the queries what you are running from the application should get the same performance. So you need to have a sample data and do the performance testing. Once these steps are over, you will do a real data migration. That means you need to move the Oracle data to Postgres. Okay, and once the data migration is over, you will do a cutover. Now, in this webinar, what we have seen is what are the how to assess, what are the tools available to assess, what are the tools to convert the schema, and functionality testing and performance testing, what are the tools there, and how to do the data migration. This will be our next webinar, but in this webinar we have covered first two stages. That means how to assess, what are the challenges you will face in the scheme, in the conversion, and what are the tools available. So we will see more in our next webinar, like particularly the data migration. How do you do a data migration? Like, what are the tools available? How do you do a performance testing? And is it a downtime? You need a downtime or no downtime? So all these topics will go in our next webinar. So this is it for this webinar. Pass on to
Yes. So thank you everyone for joining us today for this webinar. Before we answer any questions, we have one quick poll for you, which I'm launching right now. Just on a scale of 1 to 10, how likely are you to recommend this webinar to a colleague or a friend? I'm going to give everyone a few seconds to answer. Right now, we're sitting at 40% of the audience have voted. 60%. I'm going to give it another few seconds. We're at 70%. Great job. You guys are all so fast. All right. I am closing the poll. Now we are going to head on to some questions that we have for the webinar. So for the first question that we have for today was, does PostgreSQL have support procedures for migration?
Stored procedures?
Well, so I think there's two things here. There is PostgreSQL, the open source database, has nascent support for stored procedures. So in the latest version, that support has started, but it's far weaker than what you have in Oracle. So it's by far not as complete. In Postgres Advanced Server, the native Oracle compatible version, yes, you have stored procedures and packages and all those capabilities. So in standard Postgres, yeah, it's there, but it's weak. In an advanced server, you have full support for store procedures.
All right, great. Another question that came in was, if a site uses Apex, would this block the migration from Oracle to Postgres?
Okay, APAC is Oracle tied software. I mean, that is closely tied with the Oracle database. Definitely, the storage objects will migrate to Postgres, but packages like code objects will be a challenge that needs a lot of manual work. I don't say that it is not, it won't migrate, but it needs a lot of manual work for that.
Yeah, but it also I think, Raghav, the UI has to be completely rewritten, right? Because APAC uses the Oracle Data Dictionary to generate the forms, etc. And so you can't assume that by going to Postgres or Postgres Advanced Server, that will all automatically work, and Oracle will not support it. So that's a bigger rewrite, yeah.
Yeah, not a rewrite.
Great. So we have time just for one more question. And the last question I'm going to read is, are there any tools, scripts, or apps which can be run in an Oracle database to check compatibility to see if they're the right candidate to convert to PostgreSQL?
Yeah, I would think try the EV migration portal. It's free, as Raghav has explained. You run an extractor, it extracts your DDL, you upload it, and you get an assessment. So you can't run it inside the Oracle database, but you don't have to, don't have to spend money, or you don't have to do a whole lot to get an assessment, right? And then, as Raghav said, there are certain rules of thumb as to where to start. If you expand that a little further, if you have, I don't know, a couple of hundred databases and you don't know where to start, our guideline is start with things where the app is written in Java, it uses an ORB, and it doesn't use it uses stored procedures that are written in PLSQL. Right? Stay away from, as Raghav said, OCI, because that tends to be much more complicated. Stay away from what's the older forms, but there's an older stored procedure function. ProC. Stay away from ProC, which is like even more difficult than OCI. But if you start with an app that's written in Java, uses an ORB or JDBC, and then you have stored procedures that only focus on PLSQL, that's usually a very good starting point. And then take that code, upload it to the migration portal, and again, that's free. It literally takes seconds, and that'll give you an idea for how easy, how hard this is going to be.
Yeah.
All right, great. So that is all of the time that we have for questions today. Apologies for any questions we are unable to get to. Thank you all for joining us for this webinar. We will be sharing this recording along with the slides as soon as possible, and I hope you have a great rest of your day.
Thank you.
Thank you.